Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Here begins the essay, Yang Hui's detailed analysis of the mathematical methods, composed in the year 1200, represents a high watermark in the development of mathematical understanding during the Southern Song dynasty. This intricate treatise provides valuable insight into the mathematical landscape of the era, offering a comprehensive overview of existing knowledge along with Yang Hui's own significant contributions. This essay undertakes a detailed, section-by-section evaluation of the work's internal claims, examining the arguments, methodologies, and evidence presented, while also touching upon the broader context of mathematical learning during Yang Hui's time. The focus remains firmly on assessing the assertions made within the detailed analysis itself, providing a nuanced perspective on its strengths, limitations, and enduring importance. Section 1, Introduction to Calculation and Numbers and Their Operations. The initial section of Yang Hui's work lays a foundational groundwork, introducing basic arithmetic operations involving integers and fractions. Yang Hui elucidates the fundamental properties of addition, subtraction, multiplication and division, with a particular emphasis on practical application. A notable claim within this section involves Yang's assertion of the necessity for absolute precision in calculations involving civil engineering projects, such as canal construction and the building of city walls. His method of reinforcing this claim relies on the use of complex numerical examples, demonstrating how even the slightest error in calculations could lead to significant discrepancies in the final result, potentially compromising the structural integrity of the project. The methodology here is primarily demonstrative, employing specific cases to illustrate the potential consequences of inaccurate arithmetic. While Yang Hui's emphasis on accuracy is undoubtedly valid, the section lacks a more detailed discussion of error propagation and its potential mitigation. Furthermore, the examples provided, while compelling, remain somewhat anecdotal. A systematic analysis of error margins would strengthen the argument. Section 2, Rules for Multiplication and Division. The second section delves into more sophisticated strategies for performing multiplication and division, moving beyond elementary operations. Yang Hui outlines various techniques, including specialized methods for multiplying multi-digit numbers and dividing fractions. He details a multiplication technique utilizing a grid system, now often referred to as Chelosium multiplication, which simplifies the process of multiplying large numbers by breaking it down into smaller, more manageable steps. One core claim here is the increased efficiency and reduced error rate achieved through the application of this grid-based method, particularly in comparison with conventional methods. The evidence supporting this claim largely stems from comparative examples. Yang Hui presents parallel calculations, demonstrating the Chelosium method alongside traditional multiplication to illustrate the former's advantages in terms of clarity and ease of execution. While Yang Hui's assertion of efficiency is well supported, it is also important to note that the Chelosium method, while visually intuitive, may initially require a steeper learning curve than traditional multiplication. A complete assessment would acknowledge this initial barrier to adoption. Section 3, The Extraction of Square Roots and Cube Roots. This section focuses on the extraction of square roots and cube roots, presenting algorithms developed for their computation. Yang Hui describes a stepwise method for determining the integer and fractional parts of square roots and cube roots, relying on a geometric understanding of squares and cubes. A central claim in this section is that the presented methods provide a universally applicable means of extracting square and cube roots, regardless of the magnitude of the number. The evidence is derived from worked examples covering a range of numerical values. While the methods presented are indeed generally applicable, their practical implementation can become notably cumbersome with very large numbers or when seeking high precision. The detailed analysis does not grapple with the computational complexity, which is an important consideration for practical calculation. Further, While Yang Hui provides geometric analogues to underpin the methodology, it doesn't specifically address the limitations regarding geometrically incommensurable numbers and their representation within this phrase. Section 4 Methods for solving linear equations. Yang Hui elaborates on algebraic methods for solving linear equations in this section, providing early examples of symbolic representation and manipulation. He introduces a technique akin to Gaussian elimination for solving systems of linear equations, presenting a significant advancement in algebraic problem solving. Yang's work asserts that all systems of linear equations with a unique solution can be solved through the methodical application of these techniques. Yang Hui supports this proposition with several examples, demonstrating the systematic reduction of systems of equations to simpler forms, ultimately leading to a solution. The lack of a general proof raises concerns about the scope of the applicability of these methods. Furthermore, the question of how to deal with underdetermined or overdetermined systems of equations remains unaddressed. A future elaboration would consider the limitations of the algorithm and clarify the conditions under which it guarantees a unique solution. Section 5 The Pascal triangle illustration and its applications. In this section, Yang Hui discusses the arithmetic triangle, now commonly referred to as Pascal's triangle, outlining its construction and demonstrating its applications in binomial expansions and combinatorial problems. Yang Hui does not claim to have discovered the triangle, freely acknowledging its prior existence. Rather, he provides a detailed explanation of its properties and practical uses. He asserts a direct correlation between the coefficients generated in the expansion of a binomial expression, such as a plus p to the power of n, and the numbers found in the corresponding row of the arithmetic triangle. This assertion is supported by numerous examples, showcasing the expansion of a plus b to various powers and demonstrating the precise correspondence between the coefficients and the triangle's elements. The section, however, lacks a formal proof of the binomial theorem, implying that this connection remains primarily empirically validated. The absence of a formal proof, while understandable within the context of the time, leaves open the question of whether the observed pattern holds true for all values of n, or whether there exist specific cases in which the correlation breaks. Section 6 Calculations of land surveying and geometry. The sixth section focuses on practical applications of mathematics in land surveying and geometry, illustrating how mathematical principles can be applied to determine areas, volumes, and distances. Yang Hui presents methods for calculating the area of various geometric shapes, including triangles, circles, and irregular polygons, as well as techniques for determining the volumes of solids, such as prisms, cylinders, and pyramids. A central claim within this section is the accuracy and practicality of the methods presented, particularly with regard to land surveying. Yang Hui supports this proposition by referencing specific examples relating to actual land measurements. While the formulas presented are indeed largely accurate, they rely heavily on the assumption of ideal conditions. The detailed analysis does not directly deal with the challenges posed by irregular terrain or the inherent limitations of measurement tools available at the time. Section 7 Various applications to practical problems. The seventh section delves into a diverse array of practical applications of mathematics, ranging from problems related to taxation and commerce to those involving military logistics. Yang Hui presents a series of numerical problems drawn from real-world scenarios, demonstrating how mathematical principles can be employed to solve everyday challenges. One notable claim is the applicability of mathematical methods to effective resource management, particularly in areas such as tax collection and grain distribution. Yang Hui supports this claim with examples illustrating how linear equations can be used to calculate equitable tax burdens and how proportions can be applied to ensure fair allocation of resources. However, a more critical examination of these examples reveals a simplified portrayal of complex societal challenges. The section does not adequately address factors such as corruption, political influence, or the practical difficulties of implementing purely mathematical solutions in a messy, Human. Section 8. Discussion of interest and financial calculations. This section explores the intricacies of interest calculations and other financial applications, offering insights into commercial practices of the era. Yang Hui presents formulas for calculating simple and compound interest, as well as methods for determining the present and future values of investments. A key point is that a comprehensive understanding of financial mathematics is essential for successful commerce and investment. Yang Hui provides numerous examples to illustrate the application of these formulas, demonstrating how to calculate the growth of investments over time and how to determine the optimal terms for loans and mortgages. However, the analysis does not delve into the complexities of risk management or the potential for financial speculation. It also lacks consideration for the ethical implications of interest rates and the potential for usury. Section 9. Analysis of volumes of three-dimensional geometric shapes. Focusing on three-dimensional geometry, the section details methods for calculating volumes of various geometric solids. Yang Hui provides formulas for calculating the volumes of prisms, pyramids, cylinders, cones, and spheres, showcasing an impressive understanding of spatial relationships. It is claimed that the presented formulas offer accurate and reliable means of determining the volumes of these shapes, facilitating practical applications in areas such as construction and engineering. Yang Hui supports this claim with a series of geometric diagrams and numerical examples, illustrating how to apply the formulas to real-world problems. However, the detailed analysis does not address the underlying principles of integral calculus, which provide a more rigorous foundation for volume calculations. The absence of calculus limits the ability to address volumes of more complex shapes. Section 10. Mathematical problems involving rate and distance. The 10th section concentrates on mathematical problems involving rates and distances, focusing on scenarios related to travel and movement. Yang Hui presents techniques for solving problems related to speed, time, and distance, providing practical tools for calculations. One central claim within this section is that mathematical principles offer an essential framework for understanding and predicting movement, particularly in the context of military logistics and transportation. Yang Hui supports this claim with a range of examples. The analysis, by and large, assumes constant speeds and straight-line paths, neglecting the complexities of variable terrain, wind resistance, and other real-world factors. These limitations should be factored into any assessment. Section 11. Introduction to circular measurement and ratios. This section introduces the concept of circular measurement and explores the relationships between different circular ratios, specifically highlighting the value of pi. Yang Hui discusses the value of pi, approximating it to a certain degree of accuracy, and demonstrates how it can be used to calculate the circumference and area of circles. The underlying claim here is that the approximation of pi, despite its limitations, provides a useful tool for practical calculations in diverse fields such as construction, astronomy, and cartography. Yang Hui illustrates this claim through several geometry-based examples. A more thorough examination reveals that the approximation of pi by Yang Hui, while sufficient for some practical purposes, lacks the precision required for more advanced calculations. This limitation should be viewed in light of alternative methods for calculating pi that were prevalent at the time. Section 12. Continue fractions and approximations. This section explores advanced topics in number theory and approximation techniques, specifically focusing on continued fractions. Yang Hui presents methods for representing numbers as continued fractions and demonstrates how these representations can be used to obtain increasingly accurate approximations of irrational numbers. The assertion lies with the power of continued fractions in approximation. Yang Hui supports this assertion with several illustrative examples. The presented examples, while technically correct, do not fully explore the theoretical underpinnings of continued fractions. A more comprehensive approach would delve into the convergence properties of continued fractions and their relationship to Diophantine approximation. Section 13 Analysis of problems involving geometric progressions. The 13th section provides insight into problems involving geometric progressions, offering valuable tools for solving challenging mathematical problems. Yang Hui presents formulas for calculating the sum of a geometric series and demonstrates how they can be applied to solve problems related to compound interest and population growth. Assertion surrounds the utility of geometric progressions in calculating cumulative values. Yang Hui supports this assertion with worked examples, demonstrating how to apply the formulas in practical scenarios. The treatment does not delve into the convergence criteria for infinite geometric series. Section 14 Detailed exposition of magic squares and their properties. This section provides a detailed exposition of magic squares and their properties, showcasing an understanding of combinatorial patterns and mathematical relationships. Yang Hui presents methods for constructing magic squares of various sizes and demonstrates their unique properties, such as the fact that the sum of the numbers in each row, column, and diagonal is the same. A claim is the inherent mathematical beauty and recreational value of magic squares. Yang Hui supports this claim through visual presentation, highlighting the symmetrical arrangements and the elegant properties of these squares. From a modern perspective, the detailed analysis does not explore the deeper connections between magic squares and other areas of mathematics. Section 15 Mathematical methods for agriculture and irrigation. The concluding section of the detailed analysis discusses the applications of mathematics in agriculture and irrigation, underscoring the practical utility of mathematical knowledge. Yang Hui presents methods for calculating land areas, volumes of irrigation canals, and water flow rates, demonstrating how mathematical principles can be applied to improve agricultural productivity. It is asserted that the agricultural productivity results from efficient resource management. Yang Hui supports this assertion through providing practical examples. The section does not address the complexities of soil science, weather patterns, and other environmental factors that can impact agricultural yields. In conclusion, Yang Hui's detailed analysis of the mathematical methods offers a valuable, albeit occasionally incomplete, snapshot of mathematical knowledge. During the Southern Song dynasty, the work presents a comprehensive overview of arithmetic, algebra, geometry, and number theory, as well as practical applications in fields such as surveying, commerce, and agriculture. While the detailed analysis lacks the rigor of modern mathematical proofs, it provides a wealth of insight into the practical problem-solving techniques employed by mathematicians of the era, and it demonstrates a sophisticated understanding of mathematical principles. By systematically evaluating the claims made in each section of the book, it becomes clear that Yang Hui's work represents a significant contribution to the development of mathematical thought. The book's enduring significance resides not merely in its factual content, but in its demonstration of the power of mathematical reasoning and its commitment to applying mathematical principles to solve practical problems.
We really appreciate you tuning in to this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.